Dear friends, welcome to another video. Today we will learn about collisions in Raylib. We will recreate the scene on the screen, a dino sprite running into a square. Whenever the dino hits the square, a hitbox turns red. Let's jump right in. Let's open the C++ starter template for Raylib that I have created with VS Code. You can download this template project by visiting this GitHub repository. If you open this template with VS Code, you can see it is organized in folders. We have to open the source folder and double-click on the main.cpp file. If we now compile and run this project by pressing F5 on the keyboard, it displays a bouncing ball example. Cool, our setup works. We are ready to start developing our project. Let's delete the ball.h and ball.cpp files and all the code from the main.cpp file. Just leave the include Raylib line and the main function just like I did. We will develop everything from scratch. Now we have to create a simple game loop. If you don't know how to create a simple game loop, please watch my detailed video called Get Started in Raylib in 20 minutes. It will teach you everything you need to know. I will quickly create a new game loop now. First, let's create the game window. Init window parenthesis 1200, 800, quotes Raylib collisions. Next, let's set the target frame rate for our project. Set target FPS parenthesis 60. Now it is time for the game loop. While parenthesis window should close parenthesis equals false curly brackets. We now have to call the begin drawing function. Begin drawing. Let's now paint the background of the window white. Clear background parenthesis white. And finally, let's end the drawing. End drawing. Our game loop is ready. The last thing we have to do is to close the game window. Close window. If we run the game now, we can see a window pops up with the color and the dimensions we defined. Cool. Let's now work on the dinosaur. We are going to use object-oriented programming to help us organize our code. We will create a dino class. This way, we will be able to reuse this code in future projects with minimal changes. As we are creating a separate class for our dinosaur, we need to separate the declaration of the class and its implementation. This is where the header file and the implementation file come into play. The header file contains the class declaration, including the class name, member variables, and function prototypes. It serves as an interface for other parts of the program to use the class. On the other hand, the implementation file, usually with a .cpp extension, contains the actual implementation of the class functions. This is where the member functions defined in the header file are implemented. Separating the class declaration from its implementation allows for better organization and abstraction of code, making it easier to manage and maintain large projects. So we will need to create two new files to create the dino class. I press Ctrl+N to create a new file and then Ctrl+S to save it as dino.hpp. I will use the .hpp extension to distinguish the C++ header files from the C header files, which have the extension .h. Now we can start writing the header file of our dino class. Pragma once. This is an instruction that ensures that this header file is only included once in a compilation unit to avoid duplicate definitions. Now we can declare our class. Class dino curly brackets and a semicolon. Our class will have some public and some private methods, so let's add public colon here and private colon here. Now the first public method is going to be the constructor, so we type dino here. We also need a destructor, so we type tilde dino here. Now, what are the basic methods we need for the dinosaur? We need an update method to update the position of the dinosaur on the screen and a draw method to draw the dinosaur image on the screen. So let's declare these methods as public methods, because other parts of the program will have to call them. Void draw and void update. These are the basic methods that our Dino class is going to have. We will add more as needed as we code our projects, but these methods express the basic functionality of the Dinosaur. Now let's think about the attributes we are going to need. First of all, we are going to need an image, so let's create this attribute as private. We won't let any other class touch this image. We will use Raylib's texture2D data structure, so we need to include it here. Include raylib.h. Now let's create the attribute texture2D image. In Raylib, texture2D is a data structure representing a 2D image that can be used for rendering graphics. Next, we need to know the position where the dinosaur is on the screen. So let's create a position attribute of type vector2. Vector2 position. In Raylib, vector2 is a data type representing a 2D point or vector with x and y components. It is exactly what we need to represent the position of the dinosaur. Now, a basic version of the Dino class is ready. Let's create the implementation file. One quick way to do it is to go to the unimplemented methods here. As you can see, VS Code notifies me that these methods are not implemented. Let's implement the constructor first. We can click on the Quick Fix button and then select the first option to create the .cpp file and the definition. Perfect. This saved us some time. Now, in the constructor, the first thing we have to do is to load the image of the dinosaur. I have placed the image that we're going to use in this game in a folder named Graphics inside our game folder. You can download all the files from the GitHub repository linked in the video description. So let's load an image from the graphics folder. Image is equal to load texture, parenthesis, quotes, graphics/dino.png. In this line, we load an image file named dino.png from the graphics directory, assuming it's in the same directory as your game script. This image will serve as the visual representation of our dinosaur in the project. We use the load texture function to load the image and then assign it to the image attribute. Every time we load an image, we need to unload it when the game is closed to free up the memory it requires. We will do that in the destructor because it is called automatically when we close the game window. Dino, : tilde dino, parenthesis, and curly brackets. Unload texture, parenthesis, image. After loading the image, we have to define the position of the top left corner of the dinosaur image in order to know where to draw it. So we're going to use the position attribute. Let's place it at coordinates 100, 100 for start. Position.x equals 100 and position.y is equal to 100. Now let's draw the dinosaur on the screen. So let's implement the draw method. Void dino, : draw, parenthesis, and curly brackets. Now we're going to use the draw texture v function to draw the image on the screen. Draw texture v, parenthesis, image, position, white. This function draws a texture 2D with position defined as a vector2. It is exactly what we need. Now we are ready to see our dinosaur for the first time. Let's go back to the main file. Here is a quick shortcut. You can press Alt+1 and VS Code will get you back to the first open tab of your project. First, let's import the Dino class. Include dino.hpp. With the class imported, we can now create a Dino object. Dino, semicolon. Now we can draw the dinosaur. In the game loop, after clearing the background, we just have to call the draw method of the Dino object. Dino.draw. If we run the game now, we can see the dinosaur for the first time. Beautiful. When we use the draw method, the dinosaur appears on the screen where we told it to be. We said we want our dinosaur's top left corner to be at position 100, 100. That's why the dinosaur starts at the top left corner of the screen. Now let's make our dinosaur respond to the player's command and move accordingly. Let's go to the dino.cpp file and implement the update method. Void dino : update parentheses and curly brackets. We want to move the dinosaur every time the player presses any of the arrow keys on the keyboard. To move the object, we need to change the position of the object on the screen. So let's give the object a speed. Let's go back to the dino.hpp file and add a private attribute called speed. Int speed. Now, in the dino.hpp file, let's initialize the speed attribute. Speed is equal to 10. Now, it is time to go back to the update method. We need to detect when the user presses any key on the keyboard. Detecting a key press with Raylib is very easy. We do this with a call to the isKeyDown function at every frame. If we detect that the user pressed the right arrow key, for example, we have to move the dinosaur to the right, which means we have to increase the x-coordinate of the dinosaur. Let's do it. If, parenthesis, isKeyDown, parenthesis, key underscore right, position.x plus equals speed. We do the same with the left arrow key, but this time we will decrease the x-coordinate of the dinosaur. If, parenthesis, isKeyDown, parenthesis, key left, position.x minus equals speed. Perfect. Now we do the same thing for the up and down arrow keys. If, parenthesis, isKeyDown, parenthesis, key underscore up, position.y minus equals speed. If, parenthesis, isKeyDown, parenthesis, key underscore down, position.y plus equals speed. Remember, to move the dinosaur upwards, we have to decrease its y position. Now that our update method is ready, we can test our code. Let's go back to the main file and call the update method. Inside the game loop, before drawing anything on the screen, we type dino.update. If we run the code now, we can see the dinosaur moves on the screen if we press the arrow keys on the keyboard. Beautiful. Now let's create an obstacle for the dinosaur to collide with. Let's create a rectangle. Outside of the game loop, we type rectangle obstacle is equal to rectangle curly brackets 800, 200, 200, 175. This line initializes a rectangle using the rectangle structure provided by Raylib. It specifies the rectangle's position with x equals 800 and y equals 200, along with its width of 200 and height of 175 pixels. This rectangle will be placed on the screen as a static obstacle for the dino to collide with. Now let's draw this rectangle on the screen. We will use the draw rectangle lines ex function of Raylib. Inside the game loop, before drawing the dinosaur, let's also draw the obstacle. Draw rectangle lines ex, parenthesis, obstacle, 5, black. This line of code draws the outline of the obstacle rectangle on the screen using the color black and a border thickness of 5 pixels. Let's run the code to see how it works. Perfect. As you can see, a rectangle has appeared on the screen. We can move the dinosaur on it, but nothing happens. Now we need to detect when the dinosaur collides with the rectangle. We can do this very easily. Raylib provides various functions to allow us to detect collisions. We will use the check collision rex function, which returns true if two rectangles collide. This is exactly what we need. We have the rectangle of the obstacle and we need to check if it collides with the dinosaur. But the dinosaur object does not have a rectangle to use. That's what we have to do now. We will create a rectangle that will have the exact same dimensions as the dinosaur image and it will be positioned at the same place on the screen. So, the top left corner of the rectangle will be the top left corner of the dino image. We know the top left corner of the dino image. This information is saved inside the position vector. We just need to find the image width and height, and we have all the information we need to create a rectangle for our dinosaur object. Let's open the dino.hpp file and add another public method to our class that will return the rectangle of our object. Rectangle get rect. Now we can press Ctrl+period and then enter to implement this method. We need to return a rectangle struct. Return rectangle and curly brackets. First, we need to enter the x and y coordinates of the top left corner of the rectangle. We already have the top left corner coordinates stored in the position vector of the dino. Thus, we can use the position.x for the x coordinate and position.y for the y coordinate. So we type position.x, position.y, comma. Next, we need to define the width and the height of the rectangle to match the dimensions of the dino image. This information can be accessed using the image.width and image.height properties. Image.width, image.height. And we have to cast these values to float. Float, parenthesis, image.width, comma, float, parenthesis, image.height. Our method is ready. Before we move on, let's draw this rectangle, which in game development is called a hitbox. A hitbox in game development is an invisible shape or area that represents the physical boundaries of a character, object, or entity on the screen. It is used for detecting collisions, allowing the game to determine when two objects interact or overlap. The hitbox doesn't always match the exact visual appearance of the object, but provides a simplified representation to make collision detection more efficient and responsive. In our case, the hitbox will be a rectangle that perfectly encloses the dino character's image. By drawing this rectangle, we can visualize where the dino's interaction occur, making it easier to debug and refine collision mechanics. In order to be able to see the hitbox, let's create a new method. So, in the dino.hpp file, we add a new method. Void draw hitbox parenthesis bool is colliding. The draw hitbox method accepts a Boolean argument called is colliding. This argument is used to indicate whether the dino character is currently in a collision state, true, or not, false. If is colliding is true, the hitbox is drawn in a color, for example red, that visually indicates a collision is occurring. If is colliding is false, the hitbox is drawn in a different color, for example black, to show that no collision is currently happening. This visual feedback will help us quickly and clearly see whether the dino's hitbox is interacting with an obstacle, making it easier to identify problems or refine game's collision mechanics. Now let's implement the method. Ctrl+period and then enter to implement this method. First, let's create a color. Color, outline color is equal to is colliding, question mark, red, colon, black, and a semicolon. If is colliding is true, we use a red color for the hitbox, else we use black color. Now we can draw the outline of the rectangle. Draw rectangle lines ex parenthesis, get rect parenthesis, comma 3, comma outline color. Our method is ready. It uses the getRect method we created earlier and it draws the outline of the rectangle it gets. Cool, let's try it out. In the main file, inside the game loop, after we draw the dino object, let's also draw the hitbox. Dino.drawHitbox parenthesis false. The method requires a Boolean argument. We set it to false for now. If we now run the game again, we can see a black hitbox appears. Very cool. Now, all we have to do is to check for a collision between the rectangle of the dinosaur and the obstacle rectangle. Let's do it. Inside the game loop, after updating the position of the dinosaur, let's check for collision. Bool is colliding is equal to check collision rex, parenthesis, dino.getRect, parenthesis, comma, obstacle. With this line of code, we check if the rectangle that encloses the dinosaur image is colliding with the obstacle, and we save the result in a Boolean variable. If the two rectangles are colliding, the isColliding variable will be true. Now we can use this variable in the drawHitbox method here. So, instead of false, we enter isColliding. We now run our code again. Perfect, our hitbox appears, and when the dinosaur is colliding with the obstacle, the hitbox turns red. Our collisions work. You can see that our system collision works whenever the dino hitbox overlaps with the obstacle. Let's make a small change to our code. Let's go to the dino.cpp file. Let's say we want to draw the hitbox only if we collide with an obstacle. So we delete this line of code and we enter another one. If, parenthesis, is colliding, and in the next line we give the hitbox a red color. That's it. Let's test our changes. Perfect. As you can see, the hitbox now appears only if we collide with the obstacle. As you can see, simple collisions like this are straightforward to implement in Raylib. The Dino class we have developed is versatile and can easily be reused in other projects. Its encapsulated structure means that its movement, hitbox drawing, and collision detection methods are all contained within the class, making it portable. If you are creating a platformer or another game where a character needs to interact with obstacles, you can quickly integrate the Dino class for smooth movement and accurate collision detection. I hope this video was useful. Thanks for watching, and I'll see you next time.